Alrighty, the last module of the year. The title of this is called Functional Groups in Organic Chemistry. The hydrocarbons that we learned about in Module 12 are the basis for organic chemistry, but the groups that are attached to those hydrocarbons give them very, very specific characteristics. And so in addition to what is presented in the book, we are also going to learn the nomenclature or the naming of these compounds that have these different functional groups on them. If you're taking advanced chemistry, it's almost for sure because you're very science oriented and you plan on taking chemistry in college. And whether you go on far enough to take organic chemistry in college, or even if you just take 1 year of chemistry, almost for sure, you will be naming all of these groups even in your first year. So I figured this is the best way to give you a heads up to make your next exposure of this much easier. And so the nomenclature that we are going through, you're not going to find in the book, but I do expect you to know it. And I provided you with plenty of extra practice problems so that you will be able to master the nomenclature of these different functional groups. So what we're starting with today are alcohols. And alcohols are often the starting components for many, many other compounds, and that's why we're starting with an alcohol. An alcohol is simply an oxygen bonded to a hydrogen that's then bonded to some other group, and that's what that R stands for. It's just some other hydrocarbon of some sort. It could be a methane, it could be an ethane, it could be a benzene ring, it could be any number of things. But the R group is just what this OH is attached to. The whole classification is called an alcohol, but the group itself, you'll often see it called a hydroxy group. So when you name these, the way that you name them is on the end of it. Like if you have a methane, which is what I would have here, I'm going to end it with an OL. That's going to be the suffix for an alcohol group. So the name of this compound would just simply be methanol. I'm going to use an OL or an AN because it's all single bonds, but then the OL on the end indicates that I have an alcohol group on it. Okay, similar to that, this would be an ethane with an alcohol group on it. So this one is going to be called ethanol. Now, obviously, we're going to have to be able to distinguish where on the chain or where on the compound the alcohol group is. In methanol and ethanol, there's only one place it can be. Ethanol, no matter which one I put it on, it's going to be the number one carbon. So the numbers on these two are not necessary. But when I get down to something bigger than that, if I've got 3 carbons, I'm going to have to specify which carbon it's on. So here I have a base of 4 carbons and the alcohol group is on the end, just like the other functional groups, or just like the alkyl groups that we were putting on, the methyl, the ethyl, the propyl. If you put a halogen on it, like a chloro or a fluoro, you want to give it the lowest possible number. Same thing is going to be true here. And so the name of this compound is going to be 1-butanol. Okay, hyphen again between the number and the word. If it's on here, I can see this one. And just like before, I want to number it from the end so that I have the lowest possible number. So I'm going to number it so that this is carbon number 1 and not this one, because that gives us a 2, where if I number it from this end, that hydroxy group is going to have a 4. So the name of this one is going to be 2-pentanol. All right. If I have other groups, well, before I do that, I want to point out that here, this alcohol group is attached to a carbon that just has one other carbon attached to it. And this one is going to be called a primary alcohol. Now, on this alcohol, this hydroxy group is attached to a carbon that has 2 other things attached to it. So this one is called a secondary alcohol. Okay, and this, you need to make sure you understand the difference between these two, because it's going to make a difference when we start talking about reactions a little bit later on in the module. So the primary alcohol is just to attach to a carbon that has one other thing. A secondary alcohol, the hydroxy group, is attached to a carbon that's attached to two other things. It is possible that if I had something that looks like this, so this would be a CH3, and this would be a CH3, and this would be a CH3, and that would just be a carbon, and then I'd have an alcohol attached here. This carbon is attached to three other things. It's where the hydroxy group is attached, and this one is actually called a tertiary alcohol. Okay? So those are the differences between the three main types of alcohols, depending on how many other things this carbon that it's attached to is attached to itself. So make sure you understand the difference between primary, secondary, and tertiary alcohols. There are a couple of practice problems in your assignment today where you'll be doing that. All right, so go on to more naming. If I look at this one right here, I'm going to give this the lowest possible number over the methyl group. So this is going to be the number 1. And so I'm going to go around in such a way so that I give this one the lowest possible number if this has the number 1. So I could go 1, 2, 3, or I could go 1, 2, 3, 4. Obviously, I want this to have a 3 in place of a 4. So the way I'm going to name this one is going to be 3-methyl cyclopentanol. Okay, I don't need to put a 1 there because it's a cyclo compound. Obviously, it's going to be on the number 1 because hydroxy groups take precedence over other alkyl groups that are going to be attached to it when you're trying to number something. Alcohol groups also take precedence over multiple bonds. So, although I have a prop base here, I could number it from this end, or I could number it from this end. Before, you would have assumed I would start here, but this alcohol group takes priority over this double bond. So that means this is going to be the number 1 carbon right here. So the proper name for this compound is going to be 2-propene 1-ol. 2-propene 1-ol. So I need to number the hydroxy group so that it has the lowest possible group, even if it means a multiple bond has a higher number. So the alcohol group is going to take precedence. Okay. Once in a while, depending on how the whole molecule is put together, you may have to name this alcohol group as a hydroxy group. So I could name this, if you recognize this, that's the benzene ring that we talked about at the end of module 12. So the name of this compound is simply going to be hydroxybenzene. Okay, hydroxybenzene. Okay, it's also possible to have 2 alcohol groups on something. And so just like if I had 2 multiple bonds, I would call it a diene. Here, this is going to be a diol. So my base is an ethane. So this is going to be, started that too quick. Let's try that again. So this is going to be 1, well, we'll get it right here in a second. Ethane 1,2-diol. Okay. You may also see it written as 1,2-ethane diol. Okay, and I believe either one of them is typically considered correct. Okay. This is actually, if you have 2 alcohols on a group, it's also called a glycol. And glycols are used in antifreeze, and they're also used as a pharmaceutical vehicle in a lot of things. I am a whole lot more familiar with glycols than I would prefer to be because I have an allergy to them. And so there are certain vaccines that contain glycol or a diol in them that I can't have simply because of the components that are in them. So just point of reference. Not too many people have allergies to them, so it's kind of a weird thing. But anyway, you would name a diol as something that has 2 alcohol groups in it. All right, finally, we talked about addition reactions in module 12. We talked about how if you take an alkene and you add hydrogen to it in the presence of a catalyst, it will turn it into an alkane. A very similar type of addition reaction is if I have an alkene and I add water to it in the presence of an acid. In that case, the double bond gets broken and I actually add an alcohol group to it, and that's the main way that we're going to form alcohols is by taking alkenes or alkynes and adding water in the presence of an acid, and then it will turn it into an alcohol group. Okay, and you'll have some practice with that as well in some of the practice problems that you're doing today. All right, so that is alcohols.